This is a video required for problem 2 in homework 2, and it's quite similar like the problem in the homework 1. And it said that x1 go through a noising channel, going to become x2, and it keeps going on with xk going to the noisy channel, become k plus 1. And then given the x1, the probability when x1 equals 0 as the input is 0.2 and x1 equals to 1 as the input get to the 0.8, and it keeps all for all the 1 less than k and less than n. And they also gave the when xk plus 1 is 0 with 0 as the input is 0.6, and opposite 1 as a 0 as the input is 0.4, and 1 as the input and 0 is output 0.3, and 1 is input 1 at the output 0.7. So the first one to find the probability when x2 equal to 1, so we need the x1 1. So here we got when the probability when x2 equals 2 is as 0 as the input, 1 is the output, and times the 0 as the input, so this is one. And it's 1 as the input, 1 as the output, times 1 as the output, so it's this one. So the total probability is 0.64. So, and we can do the check by getting the 0, because the total probability is 1. So when there should be a 0, is 0 as input, there's output, times the input probability is 1, and the 1 is input, 0 is output, and as the probability is 1, so the total is 0.36. So the plus it is together is 1, and it's checked. And the second is find the x3 equals 1 probability. So it's similar like the first one. So we can do the when x2 equals 0 as the input and 1 is output, and is the time is 0 the input is this one, and 1 is input, 1 is output, so times is this one, so it's plus together is 0.592. And we can check also by calculating the x3 equals to 0, and 0 is output, there's input, there's output, so this one, and 1 is input, 0 is output, is this one, so it's 0.408, it plus it's 1. It also checks. And third one is finding the x3 is 1 when x1 is 0 as input. So we can do the math matrix. So this is x3 equals to 1, the probability is 0.08 and 592, and times the initial 4 different probability when x0 as the input, 1 is input, and 0 is output, so 1 is output is this one. So we get 0.48, 0.52, 0.39, 0.61 is the output. So is it from this one here, 0 input, 0 output, 0 input, 1 is output, 1 is input, 0 output, and 1 is input, 1 is output, this one. So we can, using the formula we got from the lecture, and we can use from this one to 1 is x3 is 1 and x1 is 1 divided by the total probability when x3 equals to 1. So from this one, 0 is 1, 0 is input and 1 is output, we times 0 and we divided by x3, and then we got the final is 0.176 is the final answer for the part 3. And fourth question is find the limit when n goes to infinity and the probability when xn equal to 0. So from here, so like the third one, we use xn and xn divided equal to the 0 and 1 by the initial probability and the 4 different probability, and we will use the nth power because we don't know like what is n. So and use 0.8, 0.2, and 0.8 divided by 2 times different force number, because this is when they goes to the infinity, they most like to nearby this number because it's 7, and we after calculate this we get when probability with xn equal to n, the nearly the probability the third is 3/7. Or we can use a different problem like set. So because we don't know if it's a 0.2 or 0.8, it probably a random number a with a y minus a to times the four different initial probability with the power 1 n, and we can get that the 0.6 times 0.8 plus 0.3 times times y minus a equal to a. It has to be the initial a. So after calculating that, we get a is same as the 3/7, and 1 minus is 4/7. So 1 a is when the initial is 0, and the 4/7 is 4/7 is the probability when the limit n goes to infinity, the x equal to 1 is 4. So thank you.